and Assalamualaikum everyone. So in this video, you are going to learn on how to balance chemical equation by using inspection method and ion electron method. And lastly, you are going to learn the oxidation number of an element in a chemical formula. So please stay with me until the end of the class. Basically, in chemistry, before we stoichiometrically relate the number of mole of known reactants in order to find number of mole of unknown product or vice versa, we must balance a chemical equation first. And balancing equation is actually the most important step before we proceed doing any calculation. So here are two different methods to do chemical balancing. We have an inspection method and ion electron method. In a chemical equation, we will have these reactants on the left side of the equation, and these are so-called product, okay, which are located at the right side of the equation. And this forward arrow showing that reactants will be converted to the products. Reactants are forming the products. And one have to make sure the total number of atoms of each element is the same on both sides, meaning that if you have one carbon on the left, you have to make sure you have one carbon on the right as well. And if you have 4 hydrogen atoms on the left, you have to make sure you have 4 hydrogen atoms on the right as well. So this is the purpose of doing balancing equation, so that you can get equal number of atoms on the left and on the right. And this too is so-called stoichiometric coefficient. Let's study the first method, inspection method. So inspection method is actually the most common way to balance chemical equation, and you have even learned this method during your secondary level. So now let's study the steps to balance this equation by using inspection method. So first of all, what you have to do is you have to write down the unbalanced equation, and you have to write the correct formula for each reactant and product. So we already have one unbalanced equation right here, okay, with their respective reactants and product. Okay, step 1 done. Step number 2, balance the metallic element then non-metallic element. So according to this chemical equation, there is no metallic element, okay, whether on the side of reactant or product. Alright, so we can skip the metallic element. Then we jump to the non-metallic element. So the non-metallic element here is carbon, okay, carbon atom. So now you can check carbon atom on the left. We have 6 carbon atom on the left, and we have 1 carbon atom on the right. So is that balanced? The answer is no. So in order to balance the amount of carbon, okay, so that it can equal with the amount on the left, so what you have to do is you have to add 6. You have to put 6 in front of the carbon atom. So now we already have a balanced or equal amount of carbon on the left and on the right. Next, you have to balance hydrogen and oxygen atoms. So we will start with hydrogen atom first. We have 6 hydrogen atom on the left and 2 hydrogen atom on the right. So again, they are not balanced. So to balance the amount of hydrogen, okay, from right to the left or left to the right, okay, you have to make sure you must pair with the highest amount. Okay, you must balance equals to the highest amount. So we have 6 here and here is 2. So what you can do is you can add 3 in front of the hydrogen. Okay, so by doing that, we already have 6 hydrogen atom on the right, and 6 hydrogen atom on the left. So hydrogen atom is already balanced. The last step will be to balance oxygen atom. Okay, so we have 2 oxygen atoms on the left, and 6 times 2 is 12 oxygen atoms plus 3 times O. Okay, so 3 hydrogen atoms over here. So 12 plus 3, So the total oxygen on the right is 15. So to balance the oxygen amount here so that it can be equals to 15, what you have to do is you have to write it down as 15 over 2. Okay? And last step, we have to check the total number of atoms of each element is the same on both sides of the equation. So now let's check once again. We have 6 carbon on the left, 6 carbon on the right, 6 hydrogen and 6 hydrogen here. Okay, and lastly for the oxygen, we have 6 times 2, 12 plus 3, 15, and here is 15 over 2, O2. So you can cancel these two. Okay, so hence you will get 15 oxygen on the left and 15 oxygen on the right. Okay, let's try other example. Alright, so we have this unbalanced equation. So let's follow the steps one by one, like what we did in the previous example. So the first one, okay, skip the second one. Balance the metallic element and then non-metallic element. So do we have metallic element in this equation? The answer is yes. We have magnesium here. So first we have to balance the magnesium. We have 3 magnesium on the left. So on the right we have 1. So to balance we have to put 3 in front of the Mg. Okay, so now we already have 3 Mg on the left and 3 Mg on the right. Okay, is there any metals left? No, we don't have any more metals here. Then we can move to the non-metallic element. So for the non-metallic element, okay, nitrogen is non-metal. So we have 2 nitrogen on the left and 1 nitrogen on the right. So it is not balanced also. So what you should do, you have to put 2 in front of the nitrogen. So by doing that, we already have 2 nitrogen on the left and 2 nitrogen on the right of equation. So next, check for the other non-metallic element, if any. Yes, we have Cl. Okay, so we have 1 Cl on the left, and on the right, we have 3 times 2 is 6 Cl. We have 6 Cl over here. And the other product here, we have 2 times 1, so 2 Cl. So total Cl on the right side is 8. So to balance with the one on the left, you have to put 8 in front of here as well. Okay? Alright, so now the next step will be balance the hydrogen and oxygen. So we don't have any oxygen atom, but we have hydrogen here. So now our hydrogen is 8 on the left, and on the right it is 2 times 4. So it is already 8. Okay, so now you already balance the hydrogen atom as well. Okay, lastly, check the total number of atoms of each element in both sides, and they have to be the same. So we have 3 magnesium left, 3 magnesium right, 2 nitrogen left, and 2 nitrogen right, 8 Cl on the left, and 6 plus 2 Cl on the right. And lastly, the hydrogen, we have 8 hydrogen here, and also we have 8 hydrogen over here. So finally, you have successfully balanced your chemical equation by using inspection method. Good job, everyone! Second method to balance chemical equation is by using ion inspection method, and this method is used to balance redox reaction. So what is redox reaction? Redox reaction is a reaction that involves both reduction and oxidation. So what is reduction reaction? Reduction reaction is a reaction that accepts electron, and oxidation reaction is a reaction that release electron. Okay, release or donate electron. So for this redox reaction, okay, they can be balanced by using ion electron method, and their balancing can be done in acidic or basic solutions. In oxidation reaction, the substance loses one or more electrons, and there will be increase in oxidation state. So for example, Fe2 plus loses its electron to become Fe3+. Okay, so we can see that the oxidation number from +2 has increases to +3. Okay, so when this happens, meaning that this reaction is so-called oxidation reaction. And it will act as reducing agent. So what is reducing agent? Reducing agent is substance which donates electron to other substances. So in this equation, we can see that Fe2 plus loses its electron. Maybe it will give to other substances to become Fe3 plus. So between these two ions, Fe2 plus is the reducing agent. Reduction is the opposite of oxidation. In reduction, substance gains one or more electrons, and there will be a decrease in oxidation state or oxidation number. So as you can see in this chemical equation, okay, in these half equations, chlorine 2 accept electron to become 2Cl minus. So in order to see the change in oxidation number, okay, we can see from this Cl2 kepada Cl minus. So in Cl2, the oxidation number is 0, and in the product, the oxidation number is -1. So from here, you can see that the oxidation number has been decreases from 0 to -1. Right. And in reduction, the substance will act as an oxidizing agent. So what is oxidizing agent? Oxidizing agent is substance which accepts electron to form, substance which accept electron from other substances. So in this example, chlorine accept electron from other substances, maybe from this reaction or some other reactions yang lain, okay, to form its anion. So these are the differences between oxidation and reduction reaction. So in this example, we are going to balance this chemical equation by using ion-electron method in acidic solution. Inspection method cannot be used to balance redox equation. So in this case, we will use ion-electron method. So kebiasaannya bagi any chemical equation yang kita tak boleh balance dengan menggunakan inspection method, kita boleh pakai kaedah ion-electron method. So I will show you the step-by-step balancing, and I hope you can follow balancing this equation all together with me. The first step is divide equation into oxidation and reduction equation. So for the first step, what you have to do first is you have to split. Okay, you have to split. This is full equation. So you have to split this full equation into two half equations. Okay, two half equations of oxidation and reduction. But at the beginning, you wouldn't know which one is oxidation and reduction yet. So the first thing that you have to do is you just have to split, okay, these two full equations into two half equations. So how to split this full equation into half equations? The first thing you have to do is you have to do the pairing. Okay, you have to do the pairing. So pairingkan yang sebelah kiri dengan sebelah kanan. Cari mana benda yang sama sebelah kiri dengan benda yang sama di sebelah kanan. So we can see that sebelah kiri we have iron, and here is also iron. So we have found our first pair. Okay, so you pairkan macam ini. And then the second component, okay, we have this manganese compound di sebelah kiri dan elemen yang ada manganese juga, okay, ion manganese di sebelah kanan. So this will be our second pair. Okay, now how about H plus and H2O? For these two, you may ignore at this step. Okay, sebab these two nanti dia akan come out sebalik, come out semula dalam our full equation with the correct balancing stoichiometry. Okay, so selepas awak dah buat pairing macam ni, so then you extract keluar this pairing and tulis di bawah. So we have Okay, second step, balance element other than oxygen and hydrogen. Okay, so balance element ini merujuk kepada metallic ataupun non-metal lah. Okay, so we have to balance the metallic or non-metallic element, okay, dahulu, and then baru we go to oxygen and hydrogen. So let's do it step by step or by half equations. So for the first step here, okay, kita boleh tengok dalam ni kita hanya ada apa? Ada metallic ion. Okay, so one metallic ion and one metallic ion. So they are balanced already. Okay, and for this part juga, okay, kita tak ada oxygen and kita tak ada hydrogen. We don't have any oxygen and hydrogen in these two. Okay, di kedua-dua belah. So we may skip step 3. Okay, step yang keempat, you have to balance the charge. Okay, balance macam mana? You have to add electron. Okay, balance the charge by adding electron at the site with greater positive charge. Okay, macam mana nak check charge ni? Okay, caranya adalah kita tengok pada nilai yang dekat atas ni. Okay, so for Fe2+, we have +2 charge, and for Fe3+, we have +3 charge. Okay, so as you can see from these two charges, they are not balanced. Okay, they are not balanced. So in order to balance these charges, maka apa yang awak kena buat adalah we have to add electron at the site with greater positive charge. Kenapa kena tambah electron pada site of a greater positive charge? Sebab electron itself E-. Okay, berapa charge dia? -1. Okay, so di sini kita ada +2 and +3. +3 adalah lebih positif than +2, so we have to add electron di sebelah kanan. Okay, nak tambah berapa banyak? Tambah sehingga jumlah charge di sebelah yang banyak ini akan bersamaan dengan di sebelah yang kurang. Okay, so in this case kita akan tambah berapa? We will add 1 electron. So by adding that 1 electron, the charge now will be -1 dekat sini. So +3 tambah dengan -1, so you akan dapat here is +2. Okay, so now by having +2 di sebelah kanan and +2 di sebelah kiri, you dah successfully balance these half equations. Okay, now in these half equations, okay, we do observe electron is located on the right side of the equation. Bermaksud apa? Bermaksud electron is released. Bila elektron berada dekat sini, maksudnya elektron is removed ataupun released. So, bila elektron remove, this reaction adalah merujuk kepada oxidation equation. Okay, so dalam redox reaction, okay, in redox reaction, kalau satu half equations ini adalah oxidation, the other one ini mesti adalah reduction. Okay, so existence of oxidation and reduction reaction di dalam sesuatu redox reaction mesti vice versa. Kalau satu ni oxidation, satu mesti kena reduction. It cannot be both of them oxidation or both of them reduction. Tak boleh, cannot. Okay, so bermaksud if after you have found out ini adalah oxidation half cell, maka this one must be reduction. So you may label this one as reduction first. Okay, so now kita akan tengok pula, okay, balancing of our second half equations dekat sini. Okay, kita start balik dengan step yang kedua. Balance element other than oxygen and hydrogen. Okay, so we have element apa? We have manganese here. So we have one manganese di sebelah kiri and one on the right side. So they are balanced already. Okay, move to the third step. Balance oxygen by adding water and balance hydrogen by adding H+. Okay, start dengan O dahulu. So di sebelah kiri kita ada berapa banyak O? We have 4 oxygen di sebelah kiri. Okay, and di sebelah kanan, we don't have any oxygen. Okay, kiri 4 oxygen, kanan tiada oxygen. So, in order to balance chemical equation, you must make sure elemen yang sebelah kiri mesti kena equivalent dengan elemen di sebelah kanan. Okay, so kiri ada 4 O, kanan tiada. So, kena buat apa? You have to balance O by adding water. So, meaning that di sebelah kanan, we have to add water. Okay, berapa banyak? So, ada 4O sebelah kiri, kanan pun mesti kena 4O. So, you have to add for water. Okay, di sebelah kanan. Okay, settle for oxygen. Next we go to hydrogen. So balance hydrogen by adding H+. So hydrogen sebelah kiri none. Kanan we have 4 times 2, 8 hydrogen. Okay, so hydrogen ada di sebelah kanan sebanyak 8. So kiri tiada. So nak mewujudkan hydrogen di sebelah kiri, maka you will have to add dengan H+. Okay, how many H+? Sebelah kanan 8. So kiri must be 8 as well. Okay, so now you have balance until step 3. So next we go to step 4. Balance charge by adding electron at the side with greater positive charge. Okay, let's check. So di sebelah sini we have 8 darab dengan plus 1. So it is plus 8. Okay, MnO4 minus. Ada berapa? Ada negative 1. Okay, so total here is plus 7. So on the right side of the equation, we have plus 2 here. Okay, tambah dengan 4 times ini 0. So 0 lah. Okay, so here we have plus 2. Okay, now we have plus 7 di sebelah kiri dan plus 2 di sebelah kanan. So definitely they are imbalance. Okay, they are imbalanced, tidak balance. So how to balance the charge? Maka we have to add electron. Sebelah mana? Di sebelah yang having greater positive charge. Nak tambah banyak mana elektron? Tambah sehingga jumlah charge di sebelah kiri ini akan bersamaan dengan plus 2. So in this case, kita akan tambah sebanyak 5 electron. So by adding 5 electrons, so now charge here will be negative 5. Okay, tambah dengan 8 and then tolak dengan 1. So you will get the new total charge here will be plus 2. Okay, so by having plus 2 charge sebelah kiri, plus 2 charge sebelah kanan, you have successfully balanced this reduction equation. Okay, so labeling of oxidation and reduction is compulsory. Insist. Okay, labeling is insist ni, labeling ni. Okay, wajib kena tulis dalam you punya half equations. Next step will be multiply half reaction or half equations with integer to get same number of electron on both oxidation and reduction half equation. So here you have to check on oxidation and reduction half reaction or half equations ini. Okay, tengok dia punya bilangan elektron. So here we have 1 electron di sebelah kanan and 5 electrons di sebelah kiri. So they are not balanced. Okay, so now what we have to do adalah darab half equations ini supaya mereka mempunyai bilangan elektron yang sama. Oxidation half equations must multiply with 5 so that the number of electrons on this part will equals to the number of electron in reduction half equations. So then we have to rewrite our half equations. So next step will be add up two half equations. So now we are going to add these two half equations, okay, in order to get a full equations once again. So in this case, you have to consider these two important things here, important points here. For the same element on the same side, we have to add, and if we have same element on the opposite side, we have to cancel. So here you can see that in this oxidation and reduction half equations, we have same number of electrons, 5 electrons di sebelah kanan and 5 electrons di sebelah kiri. Okay, so these are the same benda, tetapi they lie on the opposite side. So bila berada pada opposite side, maka what you have to do is you have to cancel. Okay, we have to cancel. And please check any other elements on the left and on the right of the equation. Kalau ada benda yang sama, okay, maka you have to consider this point also. Okay, so seems like we don't have any similar things on the left and right of the equations. So now kita akan proceed dengan add up these two half equations. Okay, so in order to add these two half equations, you kena kumpulkan. Okay, the one that is on the left hand side here, okay, akan ditulis sebagai reactant, and the one is on the right side of equation akan ditulis sebagai product. So this is our overall equation or full equation. So the one yang we cancel just now, okay, takkan berada dalam our full equation anymore sebab kita dah cancel. Cancel means tolak. Okay, cancel means tolak. Okay, so now the last step is you have to check the overall equation. So what you have to check on this overall equation, of course, you have to check atoms. Okay, make sure they are balanced at both left and right side of the equation. Dan yang kedua, you have to check once again the charge. So make sure the charge must be equals di sebelah kiri dan juga sebelah kanan. So here we have 5 iron sebelah kiri and 5 iron sebelah kanan. So it is balanced. 1 manganese and 1 manganese. Untuk oxygen, we have 4 on the left and 4 on the right. Hydrogen kita ada 8 kiri and 8 di sebelah kanan. So for the atoms, they are all balanced. Okay, so how about the charge? So for charge, here we have 5 times plus 2. So here will be plus 10. Okay, and then we have to add dengan negative 1 here and plus 8. Okay, so total on the left, charge on the left will be plus 17. And for the right side of equation, we have 5 times plus 3. So this will give plus 15. And then we have to add with plus 2. And here is 0. So the total charge here will be plus 17. So now, since our charge is plus 17 on the left and also plus 17 on the right side of the equation, maka kita boleh kata bahawa you have successfully balanced this chemical equation in acidic solution menggunakan ion electron method. Okay, so untuk charge ini, you have to make sure, untuk charge, you have to make sure that the bilangan of the charge must be balanced di sebelah kiri and sebelah kanan. So it doesn't matter what will be the nilai, okay, and it is not supposed to be 0 nilai charge sahaja. Okay, it can be any charges value, asalkan the amount of charge yang sebelah kiri and kanan ini should be sama. Okay, it doesn't need to be 0 only. Okay, it could be any values. It could be in positive. Okay, the charge could be, okay, the charge here, the charge could be in positive value, negative value, and even 0. Okay, so asalkan dua-dua nilai charge kiri dan kanan ini sama, okay, you dah pendapat a balanced chemical equation. Okay, so this is your answer. Okay, this is your answer untuk balanced equation in acidic solution, okay, by using ion electron method. So again, remember to check after obtaining the final balance equation or overall balance equation, make sure you check on this. Total number of atoms of each type must be the same in both sides, on the left and right of the balance equation. And the second one, total charge of each kind, both sides must be the same. This is what we have done in the previous slides. Okay, so you just have to check the total charge here. So the way to check the total charge, I have shown you in the previous slides. Okay, so 5 times 2, this one is negative 1, and this one is plus 1 times 8. Okay, so get summation of this charge value, so you will get plus 17. You should do the same thing for this equation as well. Okay, the right side of the equation as well. So 5 times plus 3. Okay, this one is plus 2 and this is 4 times 0. So this will give you summations of plus 17. So by having the same figure, charge value or number of charge di sebelah kiri and sebelah kanan, okay, menandakan you dah pun you dah pun successfully balance that chemical equation correctly. So here are the steps to balance redox chemical equation by using ion inspection method in basic solution. The first step, you have to follow the sequence of steps just like in acidic solution or acidic medium. Then we have to add OH minus ion to both sides of the equation. Maksudnya tambah OH minus ion di sebelah kiri dan kanan of the balanced chemical equation. Kenapa? Sebab so that it can combine with H plus to form H2O. So this step must be done in order to eliminate presence of H plus. Okay, because why? Because we want to balance this equation in basic medium or basic solution. The number of hydroxide ions added is equal to the number of hydrogen ions in the equation. Okay, this means that if we have, for example, 8H plus. Okay, for example, if you have 8H plus in the balanced chemical equation, so meaning that you have to add sebanyak 8 OH minus. Okay, supaya combination of these two you will get 8H2O. Okay, and this step also diperlukan untuk apa? Untuk nak eliminate presence of the H plus. So let's try to balance this equation in basic solution together. In this example, we are going to balance this chemical equation by using ion electron method, but this time it is in basic solution. So here are some of the steps, and if you can see, those steps are actually the same steps that we use in balancing equation in acidic solution, okay, as in the previous slides. So we will start with the same step, iaitu divide equation into oxidation and reduction half cells or half equations. So daripada sini, what you should do adalah you have to split these full equations into two half equations. So how to split them? You have to do pairing. So you pair anything similar on the left side of the equation with the right side of the equation. Okay, so we can see that in this molecule we have chromium containing. Okay, it is chromium containing molecule. Okay, and you should pair with the chromium containing ions over here. Alright, so hence from there you will get the first pair. And then we also have iodine containing in this molecule, and we pair with the iodine atom, the iodine ion, sorry, okay, on the right side of the equation. And for these two, OH minus and water, okay, for this initial step, macam biasa, you have to ignore dahulu. Alright, so now you have to rewrite the pairing. So now we already have our two half equations. Okay, but we don't know yet which one is oxidation or reduction half equations. So we will proceed with step 2, balance element other than oxygen and hydrogen. So I'm going to do for this half equation first, and then baru I move to the second half equations. So in this half equations, we have chromium. Okay, metal here. So make sure you balance chromium di sebelah kiri and sebelah kanan. We have one chromium here, and this is one already. So it is already balanced. And then yang ni done. Okay, and then we go to the step 3. Balance oxygen by adding water and balance hydrogen by adding H+. So check for the oxygen first. We have 1 oksigen darab dengan 3. So maksudnya 3 oksigen di sebelah kiri, dan kita ada 4 oksigen di sebelah kanan. So maksudnya 4 dengan 3. It is imbalance. Tak balance lah. Okay, so in order to balance the amount of oxygen, so apa you kena buat? You have to add water. Tambah di mana? Of course, tambah di sebelah yang kekurangan oksigen. So yang kurang oksigen adalah sebelah kiri. Kurang berapa banyak? Kurang 1 sahaja. So tambahlah 1 molecule of water sahaja. So by doing this, you dah ada 3 oksigen tambah 1. So 4 oksigen di sebelah kiri and 4 oksigen di sebelah kanan. So balance the oxygen already. Okay, and then balance hydrogen by adding H plus. So let's check for the hydrogen. Hydrogen here we have 2. Di sini kita ada 3 darab 1. So 3. 3 hydrogen tambah dengan 2. Bermaksud we have total of 5 hydrogen di sebelah kiri. And sebelah kanan we have none of them. None hydrogen. So to balance the hydrogen, you have to add H plus di sebelah yang kekurangan hydrogen tersebut. So bermaksud we have to add H plus di sebelah kanan. Berapa banyak nak tambah? We have to add sebanyak 5 lah. Kerana kita ada 5 hydrogen sebelah kiri. So, kanan pun mesti kena 5H plus. So now we have balance until step 3. Next one, balance electron. Sorry, this is not electron. You have to balance the charge. Balance the charge. Buat macam mana? We have to add electron at the side with greater positive charge. First of all, we have to kira dahulu charge kiri dan kanan. So, di sini kita ada charge 0. Yang ini pun adalah 0. So, we have 0 charge here and 0 charge di sini. Sebelah kanan we have negative 2 and sebelah kiri kita ada plus 5. So, total here akan jadi plus 3. Now, how to balance the charge? Di sini ada kosong, ini plus 3. Bermaksud charge is imbalanced now. So, this equation is not yet balanced. This equation is not yet balanced. So, to balance the charge, kita mesti kena tambahkan electron at the side with greater positive charge. So, antara kiri dengan kanan, we have greater positive charge di sebelah kanan. So, meaning that you have to add electron di sebelah kanan lah. Nak tambah elektron berapa banyak? You must add elektron sehingga total charge sebelah kanan akan bersamaan dengan yang sebelah kiri. Akan bersamaan dengan sebelah yang kurang tadi tu. So, in this case, kita perlu tambah sebanyak 3 electrons. So, by adding 3 electrons, so plus 3 minus, plus minus 3. Bermaksud sekarang ni, our new total here akan becoming 0. So by having 0 charge sebelah kanan and 0 charge di sebelah kiri, maka you already balance this equation. Now, our electron here is located at the product side, di sebelah kanan. Bermaksud electron is removed from this reaction. Bila electron ini adalah remove, maka this equation adalah equation of oxidation. Ini adalah oxidation. Dan yang lagi satu dekat bawah ni, confirm lah, dia akan jadi reduction. So that is the way you identify reduction and oxidation half equations. Settle untuk oxidation half cell, then we move to the reduction half cell. So you follow exactly step yang ini semula. Alright, let's start with the balance element other than O and H. So we have one iodine sebelah kiri and one iodine kanan. Settle, balance. Next, balance oxygen. We have 3 oxygen kiri, kanan is 0. So, we have to add sebanyak 3 water di sebelah kanan. Kenapa? Because we have 3 oxygen kiri. Kanan tiada apa-apa oxygen. So, you have to add 3 water. So, now oxygen dah pun 3. Next, balance the hydrogen. So, to balance hydrogen, we have hydrogen. 6 hydrogen sebelah kanan. Kiri, none hydrogen. So, you have to add 6H plus. So now you already balance everything, the element O and H. So now balancing the charge pula. So to balance the charge, you have to calculate the charge di sebelah kiri. Kita ada plus 6 and here we have negative 1. Total here will be plus 5. And then we have negative 1 here and here is 0. This is negative 1. So the charge plus 5 and negative 1, it is not equal, tak sama. So this equation still is not balanced. So to balance the charge, apa you kena buat? You have to add electron at the side with greater positive charge. Which side yang having greater positive charge? Yes, of course yang sebelah kiri. Okay, so you have to add elektron yang di sebelah kiri. Nak tambah berapa banyak elektron? Tambah elektron supaya the value of charge nanti akan equals to yang kecil ni. Okay, yang di sebelah kanan ini. So, in this case, you have to add sebanyak 6 electrons. So, by adding 6 electrons, okay, negative 6 plus 5. So, now you akan dapat negative 1 charge di sebelah kiri. Okay, dan juga negative 1 charge di sebelah kanan. So, now you have successfully balancing these two half equations. And untuk equation yang kedua ini, why it is reduction? Because we have elektron di sebelah kiri. Menunjukkan bahawa elektron is accepted. Okay, elektron diterima oleh this equation. So next, you have to multiply these half equations with integers so that the number of electrons on oxidation half cell should equals to the number of electrons on the reduction half cell. So in this case, we have to times this equation with 2 so that the number of electrons here will be 6 electron sama dengan elektron yang di sebelah kiri tersebut. So next we have to add these two half equations. So same element on the same side you have to add, and same element on opposite side you have to cancel. So in this case, we have 6 electrons di sebelah kanan dan 6 sebelah kiri. So they are same benda, tapi on opposite side, maka you can cancel. And then what else do we have? We have 6 hydrogen plus sebelah kiri and 10 di sebelah kanan. So they are same element but on opposite side, so we can cancel as well. So to cancel this, 10 minus all 6 here, so kita akan ada 4 remaining H plus. And for water, we have 2 water here and 3 water here, so they are sama juga on the opposite direction. So you may cancel 3 minus 2. So we have no more water here, and here will be 1 water. Then we check the overall equation. We have to make sure all atoms on the left must be equals with the one at the right side of the equation. So we have 2Cr here. Here is 2Cr. And then oxygen, we have 3 times 2, 6. 6 plus 3, 9 oxygen. So here we have 4 times 2, 8. 8 plus 1, 9 oxygen. Hydrogen, we have 3. Okay. Hydrogen, 3 times 2, 6. So for here we have 4 plus 2, 6 hydrogen as well. And for I, 1 sini and 1 di sini. So untuk atom, they are all balanced. And for the charge, we have here is 0, negative 1. Total is negative 1 di sebelah kiri. And kita ada negative 4 plus 4 and negative 1. So total di sebelah kanan, charge sebelah kanan pun adalah negative 1. So here we have negative 1 charge sebelah kiri and negative 1 charge sebelah kanan. So both atom and charge are already balanced. So next, this is your answer if we balance in acidic solution. Okay, but now, okay, untuk kita punya task kali ni, you need to balance in basic solution. So untuk basic solution, kita kena ada tambahan satu lagi step, iaitu eliminate H plus by adding OH minus at both sides. Okay, at both sides. Okay, tengok dekat sini, do we have H plus ion? We don't have H plus ion. Do we have H plus ion di sini, di sebelah kanan? Yes, we have 4 H plus ion. So in this case, apa maksudnya yang ni? We have to eliminate this H plus ion. Eliminate dengan cara apa? Dengan cara kita tambahkan OH minus. Okay, tambah berapa banyak? Bila yang ini ada sebanyak 4H plus, so you have to add with the same amount of OH minus, iaitu 4OH minus lah. Okay, so in this case sebelah kanan ni, sorry, I tak cukup tempat, so I just put on top of it. So 4OH minus sebelah kiri, and sebelah kanan pun akan tambah dengan hydroxide ion yang sama. Okay, so itu maksudnya adding OH minus at both sides. Okay, at both sides. So now 4H plus with 4OH minus, so this will form 4 water. Okay, so this will form 4 water. So we have 4 water here and 1 water. So we have water on the same side, same element on the same side. So bila on the same side, maksudnya we have to add. Okay, so 4 plus 1, the answer is 5. So in our final equation, you have to write di bawah ini. And once again, you can check the amount of atoms sebelah kiri and kanan, and also the charge lagi sekali. Okay, so we have how many CR? So we have 2 CR, kiri and kanan. We have 1 I, kiri and kanan. We have as much as 4 plus O, 3 times 2, 6. So 6 plus 4 is 10. 10 plus 3, 13. So here we have 4 times 2, 8. 8 tambah 5 oxygen, 13. And for hydrogen, we have 3 times 2, 6 hydrogen plus 4 is 10. And sebelah kanan, kita ada 5 times 2, 10 hydrogen. Okay, so for the atoms, we have successfully balanced all the atoms sebelah kiri and kanan. And for the charge, we have -4 here. This one is 0. This is -1. So total di sebelah kiri adalah -5. Dan di sebelah kanan kita ada -4, this is 0, and -1. So total here is also -5. So by having a balanced charge kiri and kanan, -5 and -5, maka you have successfully balanced your equation in basic solution. So this is your answer untuk balancing in basic solution. And yang biru tadi ni, okay, should be your answer untuk balancing in acidic solution. Oxidation number or oxidation states. Students could identify whether the reaction is oxidation or reduction based on the changes in its oxidation number. So here are the rules for assigning oxidation numbers. So first one, in the form of free element or uncombined, such as Na, magnesium, aluminium, nitrogen gas, hydrogen gas, their oxidation number is 0. Okay, in the form of uncombined, meaning that they stand alone, they exist alone like this. And for pure compounds and neutral molecule, like in this example, their oxidation number of this molecule and compound also is 0. Okay, how do we know? You can refer to the top charges over here. Okay, there's no charge on top of the compound of or molecule, so meaning that the total oxidation number of this molecule and compound is 0. Next, fluorine and other halogens. So basically for fluorine and other halogens, their oxidation number is -1. Unless when halogen combine with oxygen. So now oxidation number will be positive. For example, Cl2O7. So in this form, when the halogen combine with oxygen, the oxidation number of halogen will become +7. Next, alkali metal ions group 1, iron, okay, and A+, K+. So the charge on top here is plus, meaning that +1. So alkali metal ion for group 1, okay, the oxidation state or number will be +1. And also, when this metal exists in the form of compound, okay, such as in KMnO4. So in the form of KMnO4, the oxidation number of K here will be +1 also, okay. But in the form of free element like this, where it is not combined with any other atoms, the oxidation number of metal group 1 is 0, okay, in the form of uncombined. But when it combines with other atoms, okay, in a structure or molecule, so hence the oxidation number will become +1, okay. And the same thing goes to alkali metal ions group 2 and alkali metal ions group 13, okay. So the oxidation number will be based on their charges on top here. So for alkali metal ions group 2, the oxidation number will be +2. Alkali metal ions group 13, the oxidation number will be +3. And also when they exist in their compounds, such as in magnesium sulfate. So oxidation number of magnesium will be +2, unless in the form of uncombined or free element like this, the magnesium alone, its oxidation number is 0. Hydrogen, when it is in the form of free element or uncombined, the oxidation number will be 0. But when hydrogen is in compound, okay, such as in HCl, HF, water, ammonia, and CH4, its oxidation number of the hydrogen here will become +1. Exception in metal hydrides. Oxidation number of hydrogen is -1. So what is metal hydrides? It is when hydrogen combined with metal. Okay, so NaH, okay, CaH2, and so on. Oxygen in compound. The oxidation number will be -2. So when hydrogen, okay, is combined with other metal or other atom in compound, its oxidation number of oxygen will become -2. Okay, exception in peroxides. In peroxides, oxidation number of oxygen is -1. So this is one example of peroxide. And also when oxygen combined with fluorine, its oxidation number will become +2. For example, in OF2. And next, polyatomic ions will take the net charge of the ion. Okay, so these are the examples of polyatomic ion. So in this polyatomic ion, in order to identify the oxidation number, you have to take the charge on top here. Okay, so the charge on top here is refers to the total oxidation number. Net charge of the ion, meaning that total oxidation number of the whole molecule. So for example, the oxidation number of this ion for the whole ion here is -1. Why? Because we refers to this value on top of the structure. Okay, Cr2O7 2 minus. Okay, the oxidation number for the whole ion here is -2. Okay, and so on. Okay, now let's try this together. Assign the oxidation number of chromium in this ion. So in this case, firstly you need to identify the oxidation number of this oxygen. So oxygen, when it's combined with other atom, the oxidation number will be -2. Okay, and this is the one yang you are looking for. Okay, oxidation number of chromium. So what you can do is, we have Cr2. Cr2 meaning that we have 2 times chromium plus we have 7 times -2. -2 is the oxidation number of the oxygen, and all these oxidation numbers should equals to the charge on top of here. Okay, so it is equals to -2, and then you can solve to find the answer. Oxidation number of manganese in KMnO4. Okay, so now you are about to find oxidation number of Mn. Okay, and of course you're supposed to know the oxidation number of potassium and oxidation number of oxygen. So oxy number for potassium is +1 because it is from group 1, and oxidation number of oxygen is -2. Okay, so now you can do your calculation to find the final answer.
Thank you for watching, everyone. I hope this video could help to enhance your understanding in chemistry. Have fun in your learning, and remember, chemistry is easy and fun.